Afternoon, everyone. It's good to be here. I'm Chris Weissopel, CTO and co-founder of Veracode. I gave my first Black Hat talk in 2006, and it was on finding backdoors in code with static analysis. Sadly, that's still a problem today, as a lot of security problems are. We have our old problems, and then we keep adding new problems. So what I'm going to talk about today is how generative AI is being used by developers and how that is going to be impacting the software development lifecycle, what problems it causes, how we might be able to solve some of those problems. First, but for those who don't know me, I was a vulnerability researcher back in the 90s. This is a picture of me and my loft colleagues testifying before the Senate. My wife says this picture never gets old every time she sees it. And this is me here with my 90s hairstyle. But what we were trying to do back then was just raise awareness that software was not being secure by design, that developers weren't actually trained in secure coding, and organizations writing critical applications weren't actually applying security as part of the development process. They were doing what we call, patch and pray, and just deal with the issues as researchers found them in the wild. Then I became pro. I joined a company called AppSec. Loft became AppSec's research team, and that was back in 2000. And of course, we were called sellouts at the time because we were coming from the hacker community and starting what I think is sort of the beginning of the new professional security community. And this is really the way we thought about things. It was secure your product by breaking into it, taking adversarial thinking, taking offensive research, and bringing that to the process of building software, which is pretty standard today, right? We do all kinds of penetration testing, dynamic analysis, static analysis on software as part of the standard way to secure it today. But that wasn't always the case, and this was something that I feel the Loft really pushed forward to change the thinking about the way that we secure software. That's me and my co-founder, Christian Ryu. So we were at the Loft, we went to AppSec, and then we founded Veracode in 2006, and the idea was let's automate all those things we were doing manually as consultants for AppSec. Let's make this an automated process so that we can have tools to secure software. And 18 years later, it's pretty standard to do that. So I want to start by setting the stage of kind of how organizations are dealing with all the vulnerabilities that are in their code today before I introduce the new challenge of generative AI. So Veracode comes out with a State of Software Security report every year. Our latest support, we did a deep dive on what I call security debt, just to understand what are organizations finding but not fixing. Because I think that's an important way of understanding where we're at when it comes to software security. So first we looked at new flaws being introduced into software, and at what rate were those new flaws introduced. And so this was a chart of every time we scanned a piece of software over time, did we see a new vulnerability in that new code change? Could be a small change, could be a big change. Did we see a new vulnerability? And in the beginning, it's around 20% of the time, 22% of the time, we see a new vulnerability. But as that software ages, as it gets older, that rate of new flaw introduction goes up. And after 5 years, we're seeing it maybe as high as 37% of the time we're getting a new vulnerability introduced. And I think that's just an interesting thing to understand. Software development teams over time on the same application get worse at writing secure code. And this could be due to it gets more complex. The code in there is older. Maybe it gets less understood by the team that's working on it now. Maybe the team has rotated over 5 years. Developers have left. They don't understand the old code. But this is just a fact of software. Software gets harder to maintain securely over time. It takes more and more effort to maintain that security, because every time you're making a code change, it's more likely you're introducing a new flaw into that code. So what that ends up causing is the concept of what I call security debt. And I define security debt as a flaw that some sort of analysis, static, dynamic, manual code review, manual pen testing found. That flaw was logged. You have a policy that says, I want to fix this flaw. This is severe enough to fix. I care about this one. So you have a ticket open about it. And what happens is, if it sits there for more than a year unfixed, I call that security debt. It's something that you're starting to accept this as risk. And our data showed that 70.8% of organizations that are our customers have security debt. And 45% of those have critical security debt. So they have security debt which is high or critical severity vulnerabilities that they haven't fixed in over a year. So obviously, we have a flaw accumulation problem. And then we looked at, well, some teams must be doing it right. Like, we have to have some organizations and teams that are fixing their code. And it turns out only about 20% of the application development teams out there are actually applying enough effort to fix and either maintain their security debt at a level or have it go down. So think about that. 8/10 of the security teams out there are making the risk in their software increase over time. Right? So it's only a matter of time before that old piece of software has a critical vulnerability in it and someone discovers it. And this is basically how that happens. So this is sort of the current state of the world. But now we have this exciting new technology. Well, first I want to talk about why does this seem to be so hard? One of the reasons is security knowledge gap. Developers aren't trained. They don't understand that they're, how to write secure code, so they're introducing code. And then when they get told to fix something, they don't know how to do it. So it sits there. Applications are getting more complex over time. We're assembling applications with components and APIs, and no one understands what's happening inside that API, or a lot of times we don't understand what's in the components. And it's very incomplete view of risk. Sometimes a team will work on some small piece of code that gets deployed into production. It works with a whole bunch of microservices and APIs, and they don't really even understand the risk that they're introducing with that chunk of code. And finally, and this is probably the worst problem, is the threat landscape keeps changing. We know open source code. We find new vulnerabilities in that open source code over time. That needs to be updated. Old code interacts with new code, causes a new vulnerability. So just maintaining code over time is hard. Someone once said, open source ages like milk. At some point, it's going to go bad, and you're going to need to fix it. And this risk just keeps accumulating, and it takes effort by the development team to keep up with that. So now we have this cool new technology called generative AI, tools like ChatGPT, Copilot, Code Whisperer, all these cool new tools that generate code for developers. And where did that code come from, right? Where did the training come from? Of course, it came from the corpus of code that's out there now. So this is how things are starting to change. And why wouldn't they? There's reports that say there's developer productivity up to 50% by using generative AI. So see, these are some of the uses that developers are using generative AI right now. I've seen data that shows up to 40% of development teams are trying generative AI or are using generative AI in their development environment. They're generating code with it, of course, which is the focus of my talk. But they're also using it for code review, just to understand old code. They're using it to fix bugs. They're using it to translate programming languages. There's a big effort that DARPA is trying to push now to translate C code into Rust code to make it safe. We'll have to see how that pans out, but language translation is a big use. Testing code, something that all developers should be doing more of. That's a good use of it. writing documentation. So there's lots of great uses for generative AI, and if you're going to get a 50% productivity boost, you're gonna use it, right? Every organization would love to hire 50% more developers than they have now, and write more software, write better software. There's also emerging uses that people are starting to use. Searching for answers, just development questions, reading log files to find the root cause of a not necessarily a vulnerability, but just a bug, right? Going through log files is very tedious, a lot of data, very hard to do debugging. So helping with debugging is a good one. And then running functional and non-functional tests. And then finally, remediating security vulnerabilities. And that's the other thing I want to talk about today. How can we use generative AI to fix all the problems that developers aren't getting to and generative AI is adding to? So if you look at how LLMs are being used or being created, there's lots of data sources that are being scraped in order to generate the LLM's understanding of how to write code in lots of different languages. And there's lots of LLMs out there. There's dozens of LLMs out there, both the big ones that we've all heard of, like Copilot and ChatGPT. There's other LLMs out there, Gemini, Code Whisperer from Amazon. There's a lot of open source LLMs that are being used by developers where they can run them locally, like StarCoder, CodeLlama, Mistral. These are being run locally. So there's a whole set of LLMs out there that all have different varying degrees of understanding of how to write code for different languages and different varying qualities of writing code in those different languages. But they're all being used by developers. And they've learned how to write code mostly by looking at open source, but also looking at documentation, looking at the different blog posts and comments, looking at things like Stack Overflow, looking at things like OWASP. So they do look at sources that have secure coding, but they look at a lot more sources, literally millions of repos, that have unknown secure coding quality. It's just unknown. So that's a very heavy weight to the model that's been built, is the corpus of code that's out there today. And the user will prompt these and say, I want to write me a Python routine that will parse this CSV file, right? And that's the kind of prompt that the developer will use. They'll prompt the large language model, and they'll get a result. Well, it turns out, and one of the largest studies of Copilot output found that 41% of the snippets of code that Copilot was generating, this is an NYU study, had a vulnerability in it, right? That's a pretty high number. But if you went back and looked at my first data where I showed projects start introducing new vulnerabilities at a rate of like 20%, and over time they introduce vulnerabilities at a rate of 37% of code changes are making a vulnerability, it kind of lines up, right? It's in the same magnitude, it's in the same ballpark. So it shows me that the LLMs have learned to write code like developers write code. Not a big surprise, but we all know developers don't write secure code, and we have to do something about that. So here's some other studies I selected to kind of give a well-rounded understanding of what kind of code quality is coming out of these LLMs. And the NYU study is a couple years old, but the other studies in the papers are all less than a year old. Because a lot of times people say, well, aren't these LLMs just getting better and better over time? And yes, they are getting better and better over time, certainly. And hopefully these numbers will improve. But this is kind of the state of where we're at now with what developers are doing. So the first study was from Wuhan University. And they found that 36% of the code snippets that were generated by Copilot had a vulnerability in them. And the way that they did this was they searched open source repos for code that was, there was comments in the code that explained that this code came from Copilot. So they went out and found real world code that is sitting out there in open source repos that has these vulnerabilities in it. So they took all of these snippets of code, they ran them through static analysis, they inspected the results and verified them, and found that 36% of these 435 snippets had a vulnerability. So again, it's similar to the other study from NYU, around 41%, where NYU actually went out and generated 1,689 small programs across C and Python. Oh, I should mention the Wuhan University was over 6 different languages. So the NYU study, actually, they generated the prompts. They came up with 1,689 different prompts asking, I think this was Copilot again, generate a program. And then they looked at the results that came out. Stanford University's study took a different approach. What they wanted to do was have a control group of developers that were writing code the regular way, give them a programming task, have them write the code, and then have another group of programmers who were told to use ChatGPT to help them solve that coding problem, right? The request to write a particular routine. And it turned out when they compared the two, the developers using the ChatGPT had more vulnerabilities in their code than the group that was just writing code the normal way. And they selected junior, mid-level, and senior developers so that they wanted to show that this finding was across all experience levels for developers. It wasn't just junior developers or just senior developers. They used all different experience levels to come up with this. The other thing that I find was really interesting is then they asked the developers after they did it, they said, how confident are you that that coding problem that you just solved, how confident are you that the code was secure? And it turned out that the developers that were using ChatGPT felt that they were more confident that their code was secure. So not only do we have less secure code coming out of the people that are using the generative AI tools, they actually think they're coming up with more secure code. So this is a challenge, right? Because a lot of these tools, it says it right on the bottom of the screen or in the disclaimers. It says these tools, generative AI, may create errors. It may answer wrong. It may create problems. Please, review this and make sure it's correct, right? Well, the developers are more confident in their code. That person in the middle that's supposed to be looking at it is actually doing the wrong thing. They're accepting the code from the code generator as trusted. So that kind of goes against what we're trying to do, right? And then finally, Purdue University did one on just coding questions, where they looked at Stack Overflow, and they selected a set of questions from Stack Overflow, and they used that as their oracle, right? Stack Overflow, they said, hey, these were highly upvoted answers. We're going to take those as references that are correct, and we're going to ask those questions to ChatGPT. It turned out that 52% of the answers that ChatGPT came back with were wrong, right? So have your developers still use Stack Overflow when they have questions. Don't have them look at ChatGPT. The other problem was the 35% of the time when they were looking and they said, which answer do you hear? Now we'll give you the blind, right? They're not showing them which. Here's 2 answers to the question. This is the Stack Overflow, but they didn't tell them. This is answer A was Stack Overflow. Answer B was ChatGPT. And they said, which one do you think which answer do you like? Which answer are you going to use? And it turned out that 35% of the time, developers preferred the ChatGPT answer, which is already wrong 52% of the time. So they actually preferred, when they selected an answer, 77% of the time they were picking the wrong answer. So they were actually, the way that the answer was presented by the LLM, in the way that the LLM likes to be confident and really give a clear answer, probably better writing style than the answer in Stack Overflow, it turned out that developers were selecting that answer. So it was wrong 52% of the time, but the wrong answer was selected 77% of the time. So, you know, this is a problem, right? There's really a big overconfidence by developers in the output of these tools. Now, Notre Dame came out with a study just a couple months ago where they said, let's build a framework, which is basically security analysis of LLMs, or SALM. And they want to measure how different LLMs compare with each other when given programming tasks. So I think this is great. And now we have sort of a metric that can be used. You can say, well, my developers are using, you know, Code Whisperer, or they're using something else. How does that stack up against the other LLMs that they could be using? I love that 50% productivity gain, but I don't want it all eaten up by having to fix a lot of insecure code, right? I don't want to take on all that risk. And so this SALM framework was built to measure how these different LLMs performed. And in the middle there is examples of how ChatGPT performed. And this was on 100 different Python programs that had asked ChatGPT to create. And you can see right there the different CWEs that they found in the code. You know, clear text storage of sensitive information. Out of 100, 14 of the examples had clear text storage of sensitive information. That's pretty bad. And so you can see there, and you know, 4 of them were in the CWE top 25. So 4 of the categories of flaws that were generated by ChatGPT were actually pretty serious flaws. And over on the left-hand side, they have this metric called vulnerability at K metric. And these were the 5 different LLMs that they tested. This is only on Python. They only tested 5 LLMs. Hopefully, you know, with the standard being published out there, we're going to see this on more languages. We'll see it on more LLMs. But they ranked them here with the Star Coder LLM being the best and CodeGen 2B being the worst. And you know, I'm hopeful that they test on more LLMs to get us a better understanding. And this could be part of that selection process that you can help your developers select. Unfortunately, a lot of developer tools are not selected on the basis of how they help security, right? But hopefully with some education, that will help. So what are the implications of this for development? I see code reuse going down. There's a lot more copying and pasting from LLM-generated code. So we're going to get code bloat, right, as opposed to finding some code out there in a package or finding and reusing some code that's already part of your program, just maybe modifying it a bit. We're cutting and pasting new code in, right? So we're going to get code bloat, more code to maintain. Code velocity is certainly going up, right? Cutting and pasting it is a lot faster. Prompting, cutting, and pasting is a lot faster than writing the code the first time. So code velocity is going up, and this is where we're getting that 50% performance increase that everyone loves. My developers are writing more code. They're solving the problems faster. But we're getting a similar vulnerability density. We have multiple studies that are showing that these code changes, these new code snippets, are somewhere between 30 and 40% have vulnerabilities in them, similar to what human developers are creating. So if the vulnerability density is similar and code velocity is going up, we're getting an increased vulnerability velocity, right? We're getting more vulnerabilities thrown at us faster as we get more productive. So as security folks, we have to figure out, what are we going to do about this, right? Are we just going to say, hey, software is going to get less secure? Obviously, no. We have to do something about it. And I think we need to apply AI to this problem. I think the only way to solve this is to use generative AI to fix the code. But you can just prompt ChatGPT, and you can just prompt some of these LLMs, say, hey, I know I have a vulnerability here, fix it. But it doesn't fix it 100% of the time. It doesn't even fix it 80% of the time. It's oftentimes wrong. And it's very confident about how it thinks it fixed it, right? So we need something that has been built and trained and tuned to fix the code faster, because what we have now is the top part of this in the red. We have finding issues, manually triaging, generating tickets, perhaps training developers, and then manually fixing. That's how a lot of teams are fixing code right now. If you're not fixing code right in the IDE or right on every pull request, you're putting it in the backlog, and it's going to become security debt. And so that red semicircle basically doesn't work now, and it's just going to get worse in the future with increased code velocity and increased vulnerability velocity. So what we need is something that's more like the bottom of this, where we can find the flaws using some method, maybe automated, maybe manual, and then we can have an automated recommended fix, and the developer can review that and accept that fix. We need something fast, or we're never going to be able to keep up. So what I'm working on, and I know other people are working on in the application security field, is training LLMs to fix code. And one of the ways you do this is you have code pairs of bad code and then the code that would be fixed. And you say, hey, this is bad code. Learn that this is bad, and learn that this is the way to fix it. And this is what you train on, right? And it gets very precise, because you're training on the languages that you're using. You're training on the CWEs that you want to fix. This is an example. The top is an example of a reflected cross-site scripting attack, where we're reading something in, a value. We're putting that in a variable, and then we're outputting that variable out, right? Without any sanitization, without any encoding. Classic reflective cross-site scripting, easy to find. Stack analysis tools, dynamic analysis tools, really good at pointing at that line of code and saying, there's your vulnerability. Now, this one happens to be able to be fixed trivially, right? We want to then prompt the developer and just say, see that new stuff in green? That's what you need to add. Here's the code. We've added it. Just accept this code change, and your vulnerability is fixed. And if we can automate this, developers don't even need to know how to fix, right? That's the real beauty of this. Trying to train developers to write secure code. I mean, we've been doing this for over a decade, right? Maybe even 2 decades. And it only has put a slight improvement in the problem. I think the only way to truly fix this, especially with the increased vulnerability velocity, is automated fixing. And I think that is a big part of the future of application security. So what we've done is we've created a curated data set. We know where the code came from. We wrote it, right? So you're not going to get any IP infringement. And we're covering all the languages and all the vulnerabilities that matter. We're not trying to boil the ocean, unsupervised learning, scraping the whole internet. No, we're going by the languages that people are using. We're going CWE by CWE and training on the things that we know are prevalent, are high impact, and you would want to fix. And training an LLM to learn that, so that the user prompt can be the vulnerable chunk of code, and then the output can be the end result. And an important part of this is supervised learning, right? Unsupervised learning is great at being pretty good at a lot of things, but if you want to be really good and approach being able to get the answer right 100% of the time, you need supervised learning, where you add new data to the training set, and you see how that affects the output. And if it affects the output to be better, you like that training data, and you like that new learning you've done. And if it affects the output poorly, you take that data out, right? And supervised learning approaches getting the answer right all the time. And you can do that if you have a limited set of languages and CWEs. It's a tractable problem. You can't use supervised learning and a proprietary data set really to write code, because the number of programming problems and challenges is immense, right? There's literally thousands and thousands of tasks that developers are prompting generative AI to do for them. So here's some overall recommendations that I've come up with when you're using AI in code security. Is like, think about the ML model you're using, or LLM model you're using for what training data is it using. Now that we have the SAL, the SALLM benchmark, that's a good proxy for understanding if that training set was good or not, or had just a lot of vulnerable code in it. Coming up with understanding licensing issues is another issue with using generative AI. It turns out that about 1% of the output of LLMs, there was another study that found 1% has code in it that is a big enough snippet of code that you can identify where that code came from. And it might be GPL'd code, right? It might not match the licensing model of the software you're trying to make, and that could be a potential IP infringement or copyright infringement. One of the other ones is when you're using these LLMs from other services and not local, is your intellectual property being leaked? Right? So that's a question that every CISO should be asking about all the SaaS services that you're using as a company, because we all know every SaaS company is saying, hey, we're using generative AI to give you better answers. Well, what are you training on? Are you training on my data? Same problem with the code-generating LLMs. Where are they training on my data, right? And that could be a concern if it's spitting out 1% of the time data, big enough code blocks that you can identify where it came from. I don't want that 1% to be my intellectual property going to a competitor. And then finally, how accurate are the generated fixes? I haven't seen a benchmark for this, so right now it's kind of a manual review of the generated fixes, but I see us evolving. We need a bunch of tools that generate fixes before we're going to start to see these benchmarks comparing them and telling us how good are they doing. And then finally, beware of human biases that are going to trick the developers into trusting the output, whether it's code or the answer to a programming question. And then I wanted to just quickly touch on, you could have a whole presentation on some of these, quickly touch on some of these other risks. One is data poisoning. People can be creating projects out there in open source that have all these vulnerabilities in them. Frankly, there are known or damn known vulnerable apps already out there in repos that are purposely apps full of vulnerabilities. Will the LLM understand that that is an app that was purposely created to have vulnerabilities, or will it just be another app that it thinks has some functionality in it, right? So developers, attackers can amp this up and create lots of projects that have vulnerabilities in it. Maybe they could even automate this. And so how does the LLM training weed this out, right? So that's a problem going forward. Recursive learning is a new emerging problem for all LLM training. And one of the latest papers on this, Ross Anderson was one of the authors. And if you know Ross Anderson, he's sort of the old graybeard of secure engineering. He recently passed away. I think this was one of the last papers he wrote, came out earlier in the year, on how recursive learning, where LLMs are learning from the output of other LLMs, actually starts to break down knowledge, and you just eventually get gibberish, and you can't recover from it. Like the original correct answers are lost, right? So as percentage of the internet becomes more and more created by these LLMs, and there are hallucinations out there, the new LLMs are just going to learn on that. That same problem is going to come to code that's generated by LLMs, right? That same exact problem. So LLMs that generate code are going to learn from code that was generated by LLMs last year or a few years ago into the future. So this is another thing we have to think about. Maybe we have to mark code. This was generated by an LLM. Don't learn from this. I'm not quite sure what the solution to that one is. Propagation of deprecated practices is another one, and that's one of the papers showed that that is one of the reasons we have vulnerabilities coming out, because the LLMs don't really know that, that code that was written 10 years ago isn't how you would write the code today. A lot of times they don't get that insight. So they propagate these old ways of writing code that you shouldn't be doing anymore. Happens a lot with crypto and different API usage. So that's a problem. I already talked about IP infringement. I think bias and fairness is something that is endemic to all LLMs. They get any bias that was written into a code base. They're going to learn that. And finally, I want to end on this one because I think this is one of the most interesting ones, is the idea of hallucinated package names and people squatting on those package names. So there's a recent study that showed that about 25% of the time, which is ridiculously high, and it's hard for me to believe, but it was in the study, that 25% of the time when you prompt, you prompt an LLM, it comes back with package names that don't exist, right? There was a famous case about a year ago where a lawyer was kicked off of a case because he submitted a brief to the judge that contained a court case precedent that didn't exist, because the tool he used hallucinated a court case that didn't exist, and he used that as precedent. Very similar to the idea of a hallucinated package, right? And it would be all well and good if the developer would go and validate that package, and that package didn't really exist, right? The problem is, what if attackers squat on those package names, right? So what this study did was it showed that 25% of the time hallucinated package names came up, but then the really important thing is persistent hallucinated package names, right? You want a name that is going to come up over and over again. If it only comes up once or extremely rarely, there's no point in squatting that package. But around 20% of the time, those hallucinated packages are persistent, and those same names keep coming up over and over again. So squatters can go and create that package, put malicious code in there, and then people are going to start using it. So this is another thing your development teams have to be concerned about. So, just to finish it off, I love generative AI in development. I think it's a powerful tool. I don't think we're ever going to go back from a 50% performance increase, but I hope you get from my talk today that the code being generated is the same security defect or vulnerability density that your developing teams are using now. It's just coming at you faster. So we need just a faster way to deal with this, right? I think that's really the only solution. We're not going to not use generative AI for this. One thing that you can do to maybe help a little bit is include security considerations in GenAI prompts. People are working on what would be the best way to prompt it and say, please generate secure code when you do this coding task. Sometimes it might work a little bit. But really the solution is let's automate the finding and fixing process so that we can take advantage of this new productivity gain. So that's all I have today. Hit me up on Twitter at WaldPond. I'm Weld at InfoSec Exchange on Mastodon. Thank you for hearing me today.